check it out. So how did I get into this? Good question. About 2 years ago, I started playing around with Arduino, and then we got that really cold winter, and our electric bill was like horrendous because we have baseboard heaters. Anyone that knows, if you don't live in Wallingford, the electric's really expensive around here. In fact, that's why I was just asking you, JR, about it. So I started doing some Googling, and I was like, I wonder how I can reduce the electric bill, or build something that can automate at least the baseboard heater so we're not spending too much money. And after doing some investigation, I found out that different thermostats, depending on how good they are, can kick in quicker. You can save some money. But discovered baseboard heaters are about the worst possible thing you can own for for heating your house. And then also trying to control the actual baseboard heaters with a Raspberry Pi, something that's quite different because of the voltage that's used. Some of you may have seen like the Nest thermostat, which a bunch of guys from Apple built. That's great if you've got regular heating, if you've got like an oil burner or a gas burner. If you've got baseboard heaters though, it's a real pain to hook it up.
Question?
Yeah.
When you say baseboard heat, you can also deliver oil to baseboard heat. So you're saying your bill is solely electric?
Yeah, solely electric.
That's the main point.
Yeah, that's the killer.
Okay.
Right. So anyway, so we had a pellet stove which we used for heating, and I was still like interested in it after. So I was like, this is awesome. How can I build some some tools anyway for the house that can do some cool things? So I then saw that the Raspberry Pi had just come out. I don't know if I forgot to bring one. Actually, I brought all the other boards, but there's probably one knocking around here.
Yeah, there's one actually hanging off the side of that book scanner, and we have a few others around. I just have to take a look if people want to look at them after.
Oh, there you go. Yeah, so the Raspberry Pi it's basically a credit card sized computer. It was developed by a guy called Eben Upton, who was a professor at Cambridge University, and he came up with an idea of building a small computer that was super cheap, which could be used for educational purposes, especially in countries like India and certain places in Africa where access to computing was just too expensive to a lot of the population. Anyway, as a byproduct of this coming out, all of a sudden tons of people like, this is awesome, it's small, I can put Linux on it, I can plug stuff into it, it's got GPIO pins, which are the little connectors on top, so I can hook electronics to it, and it exploded. They sold, I think, like 2 million boards within a couple of years, which I think they're expecting about 10,000 over a year. So it really took off. So having purchased one of these and having this interest in trying to automate stuff, I was like, great, I'm going to build some projects. So on my blog, which I started back in 2012, there's a whole bunch of little projects in here I started experimenting with. And as a byproduct of this, Pack Publishing got in touch with me because the Raspberry Pi had only been out for maybe 8 months at that point, and said, are you interested in writing a book on it? Because there's really not much material out there. And I was like, sure, that sounds like fun. I've never written a book before. I'll give it a go. So I was like, great. So the plan originally was to build a bunch of electronics projects with the Raspberry Pi and use something called a GURT board. And the GURT board was basically a bunch of electronics on a circuit board that you plugged on the top of the Raspberry Pi that allowed you to do control motors, and it had an analog to digital converter and similar things on it. So I planned out the book, and then the GURT board didn't arrive, and then a month later it still hadn't arrived, and then a month later it still hadn't arrived, and now it's like, okay, so what are we going to do? So I went back to the publishers, and they were like, well, we could try something with Arduino. So I was like, great, I've been playing around with the Arduino, let's do that. Then I found out there's a company over in Spain who do something called the Cooking Hack Shield, which is here if anyone wants to take a look, pass it around. And this actually allows you to plug it onto the top of the Raspberry Pi, and then you attach Arduino shields to it. And a shield in Arduino terms is a circuit board that has extra functionality that you can attach to the top of say this. So this one's an Ethernet board, which is so with this technology and the Raspberry Pi, I now had a solution. I can take the Arduino shields, I can take the Raspberry Pi, and I can build a bunch of projects which basically allow you to do home automation devices with a handful of electronics. And that's the background of how we got started. So as I started the project, I then discovered that there's a lot of people who are really into this. The commercial devices are really expensive, and I did a lot of research on the history of the subject matter, and X10 was a standard that came out. The devices and that were really expensive. All of a sudden, you've got all this open source technology in the web. Anyone was like capable of basically going and buying the parts for less than $100 and building out their own devices. So it explodes on the web, and I was like, great, we'll do some of these projects and we'll put them in the book with the help of Pat. And I brought a copy of it. So
you finished your book?
Yeah, I did. This is the second edition. Yeah. So JR, this is for you guys.
All right, awesome.
Yeah.
Thank you.
It's a donation. So, but yeah, while I was doing this background research and the cost of it, it's quite fascinating. Really, back in the 60s, in popular mechanics, there was people who came up with the first home automation computer, and it was the size of a room. It's worth checking out. There's a link in there. You can go see the magazine online just to see how cool it is and how clunky it is compared to today. So, yeah. One of the fascinating things as well about this is that with the open source of all this technology, you are no longer locked into, I can't see the data. So with something like the Nest, you've got no real way of accessing any of the data that's being generated by any of the devices in your house. It's all locked down into the app you get on your iPhone. Whereas with the open source stuff, you can pretty much do anything you like with it. Once you've got it set up and controlling your baseboard heaters, you can pull that data in, you can analyze it, you can see how much electricity devices are using, you can build like a web page which will like average over time, you know, how much you're spending on electric. It's really cool. And some of those ideas are in the book. There's a technology in there called HTSQL, which allows you to put a small server over a database, and you can query it from a web page in your house. You just type in a URL and it'll bring back data. So there's lots of fun things in there. So yeah, so that was the background. I thought next what we can do is maybe look at some of the other devices. So, sure, yeah, go for it.
So I'm presuming just flipping through this book, and again, I'm walking in here with like zero understanding of anything electronic or mechanical. The person that's going to pick up this book is going to be well versed in that and starting his own projects and stuff already. It's not an introduction to how everything works. It's just an introduction to how this works with your current, if you're already a tinkerer and doing stuff, right?
Yeah, I'd say it's novice for makers, but not novice for computer users. So if you're familiar with Linux or you've done a bit of programming, then you'll have no problems with that. If you're a complete novice and you never use Linux, then there's probably a steep learning curve, yeah. But it's one of those things, if you stick with each of the chapters, I think you get it eventually. It's not too difficult. Unlike the first edition of the book, when that came out, setting up the Raspberry Pi was a lot more difficult. Then you had to have a lot more technical knowledge, whereas now you can just buy the SD card with the bootloader on it or with a copy of Raspbian installed on it. So a lot of the complexity's been taken away because they've tried to make it easier, you know, for younger computer users to use. So yeah, the other device was the Arduino. So the first edition of the book came out. It used this cooking hack shield with the Raspberry Pi. After it being out for about a year and a half, the publishers came back and were like, this sold really well, do you want to do another one? And one of the criticisms was that although it was called Raspberry Pi Home Automation with Arduino, it didn't actually use an Arduino microcontroller. So I decided that's a really valid argument. So we rewrote the first part of the book to start off using the Raspberry Pi in conjunction with this. So you might want to take one.
I'm sorry, what does this thing do?
That's a microcontroller.
Okay.
So
it's Raspberry Pi.
Right. Well, the difference between the two though is the Raspberry Pi is essentially in many ways it's a computer because you can load an operating system onto it, and it has you know, built-in USB, and it has built-in Ethernet, and it has audio, and it's got HDMI on it. Whereas this is literally just a microcontroller. The chip here, you have to upload a small program to it. It's got very limited size.
Why would anybody want to marry it?
Right. So that's a good question. So these are a lot cheaper. So one great thing about this is I can take the Raspberry Pi and turn it into like the central controller of a system, and buy that for say $35, and then you can actually just buy this there, the chip, and build your own board for less than $10. And then you can take these and you can put them in lots of different places. So if I was to do that with the Raspberry Pi, if I want to do 10 of them, that's $300 versus 10 of the ones you build yourself is only $100. So what you can basically do with these then is set them up as a thermostat or as a package sensor, and have it send all the data back to the Raspberry Pi. So it's a lot cheaper to use. Sorry guys, did you want? Yeah.
So this board actually integrated the CPU memory stuff.
No, that's the Raspberry Pi has the CPU and everything integrated in it. This is just purely it uses just a little microcontroller here. Yeah. In many ways that is like a CPU and memory
Right.
integrated, but it's
Not as powerful.
Yeah,
as
nowhere
the
near as
Raspberry
powerful.
Pi. Okay.
Right.
So you are using Raspberry Pi as the central control, and
Yeah.
then these things as like the.
Thermostat or package sensor.
Okay.
Right.
Okay.
The other benefit of this is it uses far less power than the Raspberry Pi. So if I want to embed this somewhere, I can run it on AA batteries. The Raspberry Pi is just going to like suck up a battery pretty quick. So they have two distinct uses, which I think is kind of neat.
So just again to dumb it down a little bit
Yeah.
for the uninitiated, you would attach something like that to your thermostat.
This would be the thermostat.
It would be the thermostat,
Yeah.
and it would feed its readings to the main hub, which
Right.
that's where it would send you something if you're remote somewhere, like not in the house, and you could control it that way.
Right.
So it's like a circular.
Yep.
Okay.
So what this would do is it send data back from, this is a thermistor built in here. This is actually just a thermometer and a humidity sensor. It would send the data back using this shield here, or you can buy a Wi-Fi shield. So I had this one plugged in, and then there's an Ethernet cable was going into my hub in my house, and it would send back periodically readings from the.
Is it an analog sensor?
Is this this is digital, this one.
So the Raspberry Pi has to have a digital sensor. It doesn't take analog inputs.
The Raspberry Pi only has digital inputs, but if you buy the GURT board, there's an analog to digital converter on here. This actually has analog and digital on it. So this side here is that's all the digital pins down there, and then there's analog pins there. So you can you can do both depending on what device you like.
So you said the Pi takes only digital, but how do you the shield that you add the cook? Is it the cook?
Cooking Hack Shields has
The analog converter.
Yeah, it has an ADC on it. Yeah.
Okay.
So yeah, right. So using this device with this plugged in, I can then send the data back to the Raspberry Pi, and then if that's connected to the web, it can send you an email. So one of the projects in the book is a package sensor, which has a force-resistant sensor on it, and when something touches it, it just triggers the Arduino to then send a message to the Pi, and then the Pi can then send out an email to me. There's some open source APIs out there which you can use to log into, I think, like UPS and I think FedEx. So you can then kind of guess which packages are arriving. It's not 100% accurate, but it gives you an idea of what you can do.
And other automations, you could automate like something for maybe your lighting system, your sprinkler system, or any of those.
Yeah,
other,
sprinklers,
like,
lights. In fact,
security system, even. I mean.
yeah, if you go online, there's hundreds of projects on there. Someone was asking me the other day about sprinklers. There's Raspberry Pi sprinkler systems. There's Arduino. There's ones for regulating how much water is used in your greenhouse on like tomato plants and stuff like that. So it's pretty good, and it's all really cheap to do, and it's.
Can it make my window unit air conditioner turn on 30 minutes before I get home?
Theoretically, yeah. Yeah. Yeah.
Because that would be really useful to me right now.
Yeah.
Isn't that hard at all? You just wire it up to an outlet and then use the AC terms to the setting you want plugged in, and then you just have the Arduino close the circuit between the actual like wall outlet and the plug.
Right. And in the book, there's some instructions how to use a relay to do that. So you can switch on, something like a dehumidifier in your basement or something. Yeah.
I think the question is always, how do you trigger that you're leaving work?
Right.
Do you use a timer or do you use?
Well, you could send it an email.
GPS.
Yeah.
You could send it. You could use GPS.
So
Yeah.
it'll send me data, but I can't send it instructions to do anything. It's one way.
You could.
I could. Okay.
Yeah. I mean, you'd have to set up, set it up so that you punch a hole in the firewall at home to get into the device, or set up a VPN or something. But yeah, you could definitely do that. Yep. So that's pretty much it. If anyone's interested, I brought this down actually as well as a present.
Oh, I love
This
presents.
this is one of the original girl boards. When you buy them now, they're all assembled. This is hundreds and hundreds of little bits, and it takes ages to do, and it's really painful. So if your soldering's not too good, but yeah, this is the first edition girl board. So there's a project for you guys if you
Awesome.
you want it. Sure. So questions, yeah.
Where do you usually purchase those boards?
Yeah, so there's some really good websites. Actually, let's bring this up here. So this one here is the Cooking Hat Shield. The only place I know you can get it at the moment is from their website, and it's in Spain, so it's in euros, so 40 euros at the moment. I'm not sure, depending on how well Greece does, it might be really worth buying a bunch of them at the moment. But yeah, that's one site. Adafruit is a really good website. They're based down in Brooklyn. Their stuff's cheap and it ships really quickly. And Element 14, which is where I got this from, they have a huge selection of electronics on there. And I think they were the first place to bring this out. It was the only place you could get it to start with. So. Yeah, so that's
What is the gap board?
the GURT board. So the GURT board attaches to the GPIO on the Raspberry Pi, and it has a motor control on there, it has an analog to digital converter on there. In fact, be easier than listing it.
So did your electric bill go down after all this?
We just bought a new pellet stove that was bigger. It does have a wireless thermostat handset though, so you can walk around the house, and depending on how cold it is, it'll trigger it. So it does have some cool features, but it's neat. So thanks a lot, guys. Yeah. Any questions or anyone wants to take a look?